calculator baggies. Okay, guys, this should go fast because we're just filling in some blanks. Okay, we're just going over some vocab. First thing you know is that a transversal is a line that intersects two coplanar lines at two different points. Okay, coplanar means that they lie in the same plane. So co means with, so they are with each other in the plane, coplanar. All right, so according to this definition, which of these lines, R, S, or T, is the transversal?
What?
Yeah, T, this one. It's intersecting lines R and S in two different spots, two different points. That's the transversal. Can you put that phone away, please, and thank you? Okay, next. Corresponding angles lie on the same side of the transversal and on the opposite sides of the other two lines R and S. So if I look at that definition, they have to be on the same side of the transversal. So I can look at this side to start with. And then opposite sides of the other two lines. So when we say opposite sides, we mean either inside or outside. So looking at angle 2 up here, do you see that that's on the exterior? So instead, I'm going to look at this other line, and I want the one that's in kind of the same spot, but on the interior. You see that? One's exterior and one's interior, but they're on the same side of the transversal. Okay with everybody? Okay, so besides angle 2 and angle 6, can you name some other pairs of corresponding angles? 4 and 8, correct. Ooh, that's a highlighter. 4 and 8. What else?
1 and 5.
1 and 5.
2 and 6.
2 and 6. We've got those highlighted. I'll write it down over here.
3 and 7.
3 and 7.
4 and 8.
Okay, we said those. Isn't that all of them?
Yeah.
Okay, awesome. Good, good. Corresponding. All right, next. Alternate interior. Okay, so these are non-adjacent. So remember, they don't share a common ray and they don't have a common endpoint. So non-adjacent. Non-adjacent angles that lie on opposite sides of the transversal. Woo! So when it says alternate, that means, what is happening? Okay, I don't know. If it says alternate, that means opposite sides of the transversal. Guys, my board is being a little weird. The interruption. Okay. So they're on opposite sides of the transversal, and if they're interior, that means that they're between lines R and S. So the interior part, whoops, wrong spot. Interior is in here. Okay, and then they have to be on alternate opposite sides of the transversal. So one of them would be 3 and the other one would be 6. See, they're inside the two lines that get crossed by the transversal. They're on alternate sides of the transversal. Everybody see them? Yeah. Okay, so what is the other pair of alternate interiors? Correct. 3 and 6, 4 and 5. Okay. All right. I'm not gonna go back and fix this right now, but I really should have been putting angle 3 and angle 6, angle 4 and angle 5. Can we just pretend like I did that correctly this whole time? Because if you write 4 and 5 on your test and their angles, you should put angle signs, and I will have to take off. I'm sorry that I did not lead by better example just now. Okay, that's my bad. All right, next. Alternate exterior angles. Okay, so if they are exterior, that means they are outside lines R and S. So here's exterior and here's exterior. Okay, if they are alternate, that means that they are on opposite sides of the transversal. So, for example, 1 and 8. Okay, what is the other pair of alternate exteriors?
7 and 2.
Good. And don't forget to put the little angle symbols in front. Oh, 1 and 8. Oh my gosh. Okay, sorry. Well, I was writing the other one, but I'd already asked you about the second pair, and you said it correctly, but I wrote down what you said, but on the wrong part. You know what I'm saying?
Yeah, I forgot.
She wrote 1 and 2. I just mixed them because sometimes I write what my ears hear instead of what my brain knows I should write. Okay. So far, so good, right? All right. Same side interiors. Okay, so interior means that they are between lines R and S in the interior of your picture. Same side kind of means what it means. It means they're on the same side of the transversal. So, for example, 4 and 6. Angle 4 and angle 6. What is the other pair? Good. Okay, can you guess what the last blank should be? Exterior. Oh man, you guys are good. Okay, exterior means outside. So that'll be out here, and then they're on the same side. Pew, pew. So I'm picking 1 and 7. What are the other pairs? What's the other pair?
2 and 8.
Good. Thank you so much for that confident response.
No problem. 8 times. Well, actually not.
All right, that wasn't so bad. That was pretty fast, right?
Is that all the minutes we're doing today?
No. Okay.
Is this whole thing the most bracket for today?
Oh, yeah. Rock and roll. What? Later. Okay. Give an example of each.
So locked in right now. On your phone.
All right. A transversal. What is the transversal in this picture? Line N. Good. Okay, now remember back from the very beginning of...
You wrote the last one down.
I did? What did I write?
You wrote 1 and 7 and 2 and 8. Oh, never mind.
Hey, us.
My brain.
Okay. I don't blame you for checking though, because my track record is...
Yeah, man.
All right, guys, remember that we can either name a line with like the points that are on the line, 2 points that are on it, right, with the arrow over the top, or we can name it with a lowercase script letter. So line N. Okay, make sure it's all scripty and fancy.
Oh, look at that. That was,
Scripty and fancy.
that's trouble.
Okay, what about a pair of corresponding angles?
Is, one and 3.
What?
1 and 7.
What? Nope.
What?
1 and 5.
1 and 5.
Oh.
And angle 5. Okay, let's do, should we just do one pair? Or should we do another pair, or are we good?
It's
Four
an
and
A
eight.
pair. That means 1.
Okay.
4 and
Okay,
8.
thank you. It does say a pair. So angle 1 and angle 5. Okay. What about alternate interiors?
3 and 5.
3 and 5. Good. Angle 3 and angle 5. Okay. Alternate exteriors.
So, angle 2 and 8.
2 and 8. Good. Obviously, these are not exhaustive lists. We're just following the directions and listing a single pair. What about a pair of same side interiors?
4 and 5.
3 and 6.
Good. Angle 3 and 6 is also correct.
Plus.
Okay, what about same side exteriors?
1 and 8.
1 and 8. Yes. All right, what about a linear pair? Remember that linear pairs are adjacent and that when you add them up, they add up to a straight angle, which is 180 degrees. 8 and 7, good.
Wait, 4 and 6. What's the difference?
Not 4 and 6. 4 and 3, 4 and 1.
No, the same side and 2.
Yep.
The same side.
Same side of the transversal.
It's the same.
Same side of the transversal.
Yeah.
Interior.
Yeah, but 6 is on the other side. 6 is on the other side.
Yeah, you wrote 6 and not 5.
Oh,
Sorry.
sorry.
I think I should just go.
All right. Did I get the other ones right?
And now Kylo's eating.
No.
It broke.
No, just go get a new one. Sharpen it later. Okay, a pair of vertical angles. Okay, so remember that vertical angles are made by pairs of intersecting lines.
5
Okay.
and 7.
5 and 7. Yes, good. Okay, any questions about those? Okay. All right. Classify each angle pair. All right, what about angles 3 and 8? What are they?
Vertically.
Good. Okay, 2 and 7?
Opposite or alternate
Alternate what?
interior.
Good. Okay, 1 and 8.
Alternate exterior.
Good.
Your phone's ringing.
Thank you. Okay, 5 and 6.
I actually have no idea what linear.
Linear pair. Good.
He just gave you lip.
Hmm.
Carson, the
Okay.
NPC kid.
All right, 5 and 8.
That's 2 same side.
Same side exterior. Good. Okay, 1 and 3.
Same side.
Oh.
No. It's transfer. No, it's corresponding.
Corresponding. Good. All right, 2 and 3.
Those bad boys are linear.
No.
Oh, wait, no. I was looking at the
Same
one.
side
I was looking at the one.
Interior. Same side interior.
Hey, Grant, ever left me again and it's over for you.
Okay, you guys are only allowed to laugh at me
Wow. What about the NBC?
because you're not allowed to bully each other. You can only bully me. Okay, 1 and 4.
What? Same side exterior.
Good. Okay, 6 and 7.
Oh no. That's that same side interior.
Yep.
Yeah.
Okay, 3 and 6.
Yeah, for real, you gotta give us some time to write this down.
Oh, I thought you guys might have done it while I was on the phone.
No, you're writing at like the speed of light, and we're writing at like the speed
Cornball.
Okay, well, you guys can abbreviate a little bit if you're getting tired.
Cornball.
Don't abbreviate on your test and quiz, but you can abbreviate if your hand gets tired on your notes.
My hand's not tired. It's just not that
It's just
bad.
you write fast. Cornball.
Okay, 3 and 6. Alternate interiors. Okay. Two and 4. Corresponding. That one, for some reason, is the hardest to see for me. I will stare at a pair of angles that are corresponding for a really long time to figure out what the heck they are. Okay, 4 and 7. Vertical.
You stare at angles with on your forehead?
Yep.
Oh.
It's like the least weird thing about me.
What?
That's concerning.
Yep. All right, 4 and 5. Alternate exterior is correct. All right, next.
Hold on. What? We couldn't see past your computer.
Okay.
So maybe you should move. Yeah, for real. You guys sit in the back. Hi, Jay Medini.
Okay. Hold on. Never mind. Not today. I'll get it from somebody.
Okay, so now we're going to talk about parallel lines and angle pairs. So, hey. Okay, this is like the meat and potatoes of what we're doing today. So, like the main event. Okay, the rest was just the entree. Okay. Okay, when our other lines, the not transversal lines, aren't parallel, all we can really do is like name the lines, and it's just knowing the vocab, right? But when our other two lines are parallel and they're crossed by a transversal, some very special things happen. So this is the important part of what we're doing today. Everybody ready?
Sure.
Okay. So if two parallel lines are cut, that means intersected, by a transversal, then our pairs of corresponding angles are congruent. Oh, a postulate or axiom is a statement that is accepted as true without proof. Okay, so this is our corresponding angles postulate. If I have parallel lines and I intersect or cut them with a transversal, then my corresponding angles are congruent. You see them? 1 and 6.
And 3 and 8.
Oh, sorry. Wait. 1 and 3 and 6 and 8, right? You see them? I did it the wrong way. I did vertical angles instead of corresponding.
Yeah.
So angle 1 is congruent to angle 3. Angle 2 is congruent to angle 4. Okay, what about the other pairs? What about angle 5? Yep, congruent to angle 7. And angle 6 is congruent to angle 8. So, you see why this is the important part of what we're doing? Because if I know that certain angles are congruent, then I can solve for stuff. If they're not congruent, then it's just, who cares, right? This is the important part. This is only true if our lines are parallel, right? If the lines aren't parallel, then I can't say any of this. All right, next one. Example 3. For each, find each angle measure. Tell which postulates, theorems, and properties you used. All right. So if I want to find the measure of angle 1, what is it according to this picture? I know that these two lines are my parallel lines. Okay. Here's my interior. Whoops, I meant to be on my shader. Here's my interior. What do you notice about these two?
They're the same.
Okay, why are they the same? Because they are, whoops. Hold on. Whoa. Okay, we don't know that one yet. Okay, we're going to back it up. Back it up. All right, look at angle this one and this one. What kind of angles are those?
Corresponding. No, it's no alternate. It's
Parallel.
No, it's perpendicular.
Dictionary.
Okay, angle, vertical angles. Thank you. Okay, so we have.
Oh, who does that right there?
Hey, up here. Okay, do you see that these two are vertical and that 1 and 3 are corresponding? You guys see how I can kind of leap across like that? Okay, so I can use the vertical angles theorem. Okay, and I can use the corresponding angles postulate. Huh? Yeah, theorem. It's an abbreviation that you are allowed to use. Yeah. Okay. Now, so what do we know about vertical angles? Vertical angles are congruent.
Yeah.
So if this one's 118, then what is this one?
118.
118. So my vertical angles theorem tells me that those two are congruent. They're both 118. What does my corresponding angles postulate tell me?
You don't need proof.
That you don't need proof. No. It says when you have parallel lines, okay, corresponding angles are congruent. Okay, so then I know angle 1 is 118 degrees.
So does this mean on our test we don't have to show our work because it technically says without proof, so we don't need proof?
You don't have to use proof to use the corresponding angles postulate. All you have to show is that the lines are parallel, and that is probably given to you.
Okay.
All right, nope, not right now. All right, guys, we're gonna hop skip. We're gonna come back to number 2 and 3. We're gonna look at this one. Okay, this one is a theorem.
We know 3.
A theorem
Yeah.
is a statement that can be proven true. Okay, our first theorem is the alternate interior angles theorem. I want you to draw a picture. Here's your parallel lines. Mark them with the little parallel arrows. Anytime they're parallel, they have those cute little arrows on them. Okay, and they're cut by a transversal. Okay, label your transversal with a little T. Has to be fancy. Remember that alternate interiors are these ones. Alternate interior angles theorem says that if two parallel lines are cut by a transversal, then each pair of alternate interior angles is congruent. Do you guys see why? Do you see how this one and this one are alternate interiors? Okay, because these two are vertical and these two are corresponding. Okay, I have to accept that corresponding angles are congruent. That is a postulate, but I can prove that the alternate interiors are congruent using the vertical angles and the corresponding angles postulate. Does everybody see how this theorem is a logical consequence of those two theorems and postulates? Everybody got it? All right, perfect. Let's go back up to measure of angle 2. Okay, measure of angle 2. What is it? 62. How did you get that? Yes. Okay, so this one and this one are a linear pair. Okay? So there is a theorem that says linear pairs. This one doesn't have to have a name. You just have to write it out. Sorry. Linear pairs are supplementary. Okay, supplementary means that they add up to what?
180.
Correct. Okay, so the 118 and the 62 have to add up to 180. All right, what about the measure of angle 3? We already did that one. We should have renumbered these angles. 118, why? Well, if we just use the given angle, what is angle 3 to the 118 that they gave us? We already wrote it. Vertical? Yeah, it's the vertical angles theorem. Okay, so it's 118. Okay. All right, back to the future. All right, let's do some more fun theorems. All right, same side interior angles. All right, look at this. Let's go back up to this picture. Sorry. Okay, guys, we said that angle 2 was 62 degrees, right? Do you see that 118 and 62 are same side interiors? These two? What do they add up to? 180. So what can we deduce about same side interior angles? Are they congruent or are they supplementary? They're supplementary. Okay. It'll help you to remember that they're supplementary because same side and supplementary, it's a whole lot of S's. Same side, supplementary. Got it? Okay. All right, so same side interior angles are congruent. Oh, I mean supplementary. Oh my God. Supplementary. Okay, that means they sum to 180 degrees. Okay, yeah. Same side, supplementary, sum to 180. Okay, what about alternate exterior angles? What do you think, congruent or supplementary? Well, let's look at the picture. Okay, so alternate exteriors, that would be like 5 and 7. Do they look like they add up to 180 or do they look congruent? They're congruent. Okay, next. What about same side exterior angles? So, for example, 5 and 6. Are those congruent or are they supplementary? Look at them. Are they the same size?
Oh,
They're supplementary.
My bad. He's your bad boy. Oh, God.
Okay, so when we have our same side, those are supplementary. Was that the end of that page? All right, guys, we are crushing it. But we're doing great. All right, in our figure, the measure of angle 1 is 104 degrees. Okay, what do these little arrows on our lines tell us? Yes, they're parallel. So that means that all of our postulates and theorems about congruent and supplementary angles will apply. Yes. So what about the measure of angle 3? What is the measure of angle 3?
The same as angle 5.
Okay, look at it compared to angle 1. What is it? Okay, whoa. Angle 1 and angle 3 are what kind of angles? Starts with a C. They're corresponding, so they are congruent. So this one is 104 because of the corresponding angles postulate. Okay, what about the measure of angle 5? 104, why? No, they're not corresponding. What is 1 and 5? What are 1 and 5? Okay, they're on the exterior. Are they on the same side or alternate sides of the transversal? Okay, they are alternate exteriors. Alternate exterior angles theorem. Okay, what about the next one? Angle 4. 76, I heard. How did you get that? Okay, so 74 is the answer, and 74 plus 104, wait, 76, oh my gosh. 76 degrees plus 104 degrees adds up to 180, right?
Yeah.
Okay, so we know that same side exteriors are what? Yes. Same side exterior angles theorem. Okay, so not only are we finding the angle, but the directions also say tell which postulates, theorems, and properties we are using. Right? So we're always defining our new angle in terms of the one that they gave us. All right, what about angle 7? Okay, there are vertical angles. So we're using the vertical angles theorem to tell us that they are congruent because vertical angles are congruent. Okay, what about the measure of angle 2? 76, because why?
Linear pair.
Correct. So linear pairs are supplementary. Linear pairs are supplementary. Okay, it's making me really nervous that you guys. All right, next. Example 5. All right, guys, do we need to do this again or are we good? It's just like the last one. All right, number 6. Find the value of the variables in each figure. Okay, so here are our parallel lines. Okay, we have 2 different transversals. So let's do one transversal at a time. Okay, I'm going to start. You guys want to start with the top or bottom transversal? Top. Okay, so we're going to start with this one. With respect to this line, what relationship do our 96 degree and 2x angle have? What are they? Are they in the interior or the exterior? Okay, are they same side or alternate? Okay, so what are they? They are same side interior, so they are supplementary. Okay, so I can say that they have to add up to what? 180. 180. So the angle relationship tells me if they're congruent or supplementary, which tells me what kind of equation I have to write. If they're supplementary, I have to add them up and set them equal to 180. If they're congruent, I set them equal to each other, right? So I say 96 plus 2x has to add up to 180 degrees.
Is 96 1?
What?
No, never mind.
Okay, subtract away the 96. What do you get? 84. So 2x equals 84. Divide that by 2. 42. This one doesn't need a degrees because there's a degree outside the parentheses. Everybody see that? Okay. All right, what about my second transversal? Here's my second one. Let me pick a different color. Pick red this time. Hey, what relationship do these have? Are they supplementary or congruent?
No.
They are supplementary because they are same side interiors.
Yeah.
So I have to say that 94 plus 3y plus 44 all adds up to 180. Okay, if I subtract the 94 and the 44 away from 180, what's left?
What?
42. Okay, 42 divided by 3 is it 14?
Yeah.
Okay, so I have a question for you. Here's your big brain question. Why can't I set 2x equal to 3y plus 44? Why can't I set these two equal to each other and solve? Okay, I just killed your brains. The answer is, I'm going to help you out because we're almost done. I'm going to help you out. Because these two lines are not the parallel lines. It's these two. Does that make sense? Like this is not the transversal, it's a parallel line. Okay, got it? Okay. Let's try this one. Okay. What do you see? Okay, here's my parallel lines. What angle relationships do you see? Start with 108 because that's one of the ones you know. For example, what is 108 compared to 2x? Alternate interior or exterior?
Exterior.
Interiors? Yep. Let me change colors. Okay. So here's my transversal. They're alternate interiors. So are they congruent or supplementary?
How are they interior? One's on the outside, the other's on the inside.
Here's my parallel lines.
Yeah.
They're both in the interior.
No, they're not. That's the. Well, they are.
Okay, don't look at this line right now. That's our transversal.
I thought that pink one was.
No, oh, that's our other transversal. Our parallel lines are the blue ones. They're on the interior of the parallel lines. They're on alternate sides of the transversal.
Wait, so does everything do it into?
For these, yes. Because we don't have any out here. Okay, are they congruent or supplementary? They're congruent because they are alternate interiors. Okay, so do I set them equal to 180 or to each other? Correct. So 2x equals 108. What is x? 54. I don't need a degrees because the degrees is already outside the parentheses. Okay, look at this one. What about the 5y and the 120? How do you know that they're supplementary?
Because they're the same side.
Same side interiors. Same side interiors. So 5y plus 120 has to add up to 180. Subtract away the 120. I get 5y equals what, 60? Divide by 5.
12.
Y equals 12. Okay, we're going to stop there.